Today we're going to be talking about the rational root theorem, and we're going to spend a couple of days working on this concept. Today we're focused on just listing out the possible rational roots, and we will go from there to find out which ones are actually factors. Now, we have used Descartes' rule of signs to determine what is the possible number of positive roots, what's the possible number of negative roots, and how many possible imaginary roots there are. And so that will help us narrow down which numbers to test and which numbers to play with as we're trying to figure out which one is the solution. So let's first talk about what this is. When you're given a polynomial and you have to have integer coefficients, so that means you can't have fractions, you can't have decimals, it had to be integer values. The possible roots, so that means what things will possibly be factors, are found by listing the factors of the constant over the factors of the leading coefficient. And so what that means, your constant is the number without the variable at the end of the problem. So negative 10 in this case, in that problem I have below. The leading coefficient, I find the highest exponent, like we did when we were determining what is the degree of the polynomial, and then I look in front of that. In this case, it's 6. So my leading coefficient on this problem below is 6. And then we're going to list all the possible ones. For each possible root, there will be a positive and a negative. But before we can start listing them, we need to find all of the possible factors. So what things will multiply to give me 10? So to get 10, I have some options. I have a 1 or a 10 that I could use to multiply to give me 10. I have a 2 and a 5 that could also multiply to give me 10. And then if I keep going through the list, 3, 4, and then I'm back to 5, that tells me that I don't have any other factors that will multiply to give me 10. So I'm going to do the same thing with a 6. I am going to list through all the possible factors that can give me a 6. And so when I start listing those, I have 1 and 6. I have 2 and 3. So I've already gone back to the beginning of my factors. So I know I've gotten through all my list of possible factors. And then what we're going to do is we're going to divide all of the factors of our constant divided by all of the factors of our leading coefficient. I circled this the wrong color. And so we are going to make a list of a lot of possible roots. And so I am going to call my possible roots PRs. And then I'm going to list. Every single thing in this list is going to have a plus or a minus sign in front of it. And what I usually do is I choose one of the numbers and keep going with that. So like I'm going to choose to do all of the ones for my leading coefficient, and I want to divide it from all of the factors of my 10. And so I'm going to go through and do my list. That's plus or minus, and it's going to be plus or minus on every single one of these. And so I know I have 4 different things I can actually divide. So I'm just going to go ahead and write plus or minus. I'm dividing by 1 each time. And then I'm going to go through the list at the top. And so I want to take and look through my list of all my different ones. So 1, 2, 5, and 10. And then I want to go through and do the same thing again, but now I'm going to start doing it with a different one of my things I'm going to be dividing. So I'm going to try with 2. And so I'm going to do plus or minus, and I'm going to go through and I'm going to write it 4 times because I have 4 different things. Oops. 2. And then I'm going to go through and I'm going to do the same thing. 1, 2, 5, and 10. And then I'm going to go through again and do this. But this time I'm going to be using the 3. So I'm going to do 4 fractions with a 3 as my denominator. And in front of every single one of these, I have put a plus or minus sign because it could be the positive or the negative of each of these roots. And I do the same thing. 1, 2, 5, 10. Then I'm going to go through and do the same thing with a different one of my numbers. So 6 plus or minus, and we'll be dividing by 6 each time. And after I've done this 4 times, that's all the different ones I could list. And so again, I'm going to go back and go through all of my constant factors. So 1, 2, 5, 10. I've run out of leading coefficient factors. And so that means I am done with my list. Now I just need to go back and simplify. So if I was to look back at these, and I'm going to go back and simplify all of them. And I looked at this first set. 1 divided by 1, that's better written as just a 1. 2 divided by 2 is better written just a 2. 5 divided by 1 is better written just as a 5. 10 divided by 1 is better written just as a 10. Then I'm going to go through the next set. And I'm going to look, okay, so is there anything on this next one? So 1/2, is there a better way to write 1/2? And the answer is no. Is there a better way to write 2 over 2? Yes. That's better written as a 1. Well, I already have a 1. And so 5 over 2, is there a better way to write the 5 over 2? No, that's the best way. 10 over 2 can be better written as a 5, and I already have a 5, so I don't need that one. 1 over 3, that's the best reduced. 2/3, that's the best reduced. 5/3, that's the best reduced. 10/3, that's the best reduced. Now let's go over to the denominator of 6. 1/6, this is the best way. We have 2/6, which is the same thing as 1/3. Well, I already have a 1/3. And so I don't need to write that again, so that one just gets marked out. 5/6, that's the smallest it goes. 10/6 is the same thing as 5/3, which I already have, so I do not need that one again. So we're going to narrow it down. We're going to get a smaller list just because there are some factors that have already been used. And so we're just going to go through and write out our list. This is all my scratch area, and you can do that on your whiteboards instead of on notebook paper if you'd prefer. And now we're going to make our full list of our possible roots. And so when we make our list of possible roots, we have the first ones, which are just the whole numbers. 1, we have 2, and we have 5 and 10. Each of those are positive and negative. Now we have our fractions where we had 2 as a denominator. And when we had those, we end up with just a 1/2. And the 2 over 1, or 2 over 2 is reduced to 1. So we don't need to write that again. And the 5/2. And then the 10 over 2 was 5, so we don't have to write that again. And so we now have the divided by 3s. So we have 1/3, 2/3, 5/3, and 10/3. Now we have our 6th. We have the 1/6, and the 5/6. Let's put a plus or minus on that one. And so that's my list of possible rational roots. And so the purpose of having these is so we can find out any possible roots that are actually a real root. And so I'm going to go ahead and get this one set up. We'll pick up with the same problem tomorrow and try out and find the ones, but we'll go ahead and get it set up today. And so we will, to check to see if the root is an actual root, you'll need to plug in to the function if the result is a 0, and we'll talk about that, but that's going to be the factor theorem that helps us do this. And once you've found the root, you divide to see if it's a factor, which it will be, and then you keep, and it narrows down your function to where you can keep going with smaller numbers. So today, all we're doing on this example is I want you to set it up and find all your possible roots. And so we're going to do this where y'all are going to pause and find different pieces. So let's go ahead, and I want you to find all the factors of the constant first. So you should have come up with a list of 1, 2, 3, 6. Now we're going to find all the factors of the leading coefficient, which is, so in this list it was a lot shorter. We had the leading coefficient was 1 and 2. And it's a lot shorter list to create. You'll find out that we really like it whenever our leading coefficient or our constant is private. It makes your list a lot smaller and easier to work with. And so we're going to go ahead and list out all the possible roots. And so I'm going to go ahead and pause it, and you're going to list out all your possible roots. And then check it with me at the end to see if you have it correct. So when you test this, you end up with having all the ones divided by 1, and those all reduced to where you had just the whole number on the top. And then we had it all divided by 2, and the 2 halves and the 6 halves both reduced, 2 halves becoming 1, 6 halves becoming 3. And we had already used the 2 numbers, so we do not have to write them again. And so your possible roots became plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1 half, plus or minus 3 halves. And like I said, if you want to, we're going to be continuing this problem tomorrow. And this problem we'll work on actually factoring out. We'll find out what are the factors that create this problem.